Welcome to another episode of our video series of the Philosophical History with Contemporary Critique.
It's great to be here. How are you doing?
I'm doing really well, thanks. I feel like today we're tackling, well, the original intellectual titan. When you think about the sheer influence of the mind we're examining, it's humbling.
It absolutely is. We're really setting out to analyze one of history's most influential thinkers, and specifically the philosophical and physical structures he built that basically held sway almost unchallenged for 2,000 years.
And that's really our mission today, isn't it? To see this thinker not as just a list of historical mistakes, which is often how he's taught.
Right, he got this wrong, he got that wrong.
Exactly. But to really get inside his worldview, to see it as this incredibly logical, coherent system. And understanding the strength is, I think, the only way to appreciate the radical break that modern science had to make centuries later.
Precisely.
Yeah.
I mean, if a system dominates Greek, Roman, Islamic, and Christian thought for that long, it had to be unbelievably compelling. And just to give a sense of the scale, we're working with about 1 million words of his surviving text.
1 million words from the 4th century BCE.
And that's the thing. Scholars think what we have is probably only a third of what he actually wrote. Maybe even less.
Wow.
Yeah, the sheer amount that people thought was important enough to copy by hand and preserve across all these different cultures, it tells you everything you need to know about his authority.
Okay, so let's start unpacking that. He was, of course, the student of the great idealist, and then he goes on to tutor this giant figure who literally reshapes the known world.
To his incredible resume, and that idea that he heavily influenced his students' imperial ambitions is it's a romantic fantasy, mostly.
Really?
Oh, yeah. When you actually look at his political philosophy, it's closed, it's conservative. It's all about the small, self-sufficient Greek city-state, the polis.
So he wasn't whispering ideas of grand, continent-spanning empires in his ear.
Absolutely not. He thought the ideal state should be small enough that you could, know your fellow citizens. That's how you get justice. An empire would have just destroyed the very moderation and self-sufficiency he valued. That conquering vision. That was all his students.
Okay, so let's talk about his own teacher. In the popular imagination, especially thanks to that famous Renaissance fresco, we see this great rivalry, one pointing up to the heavens, the other down to the earth.
Right, the ultimate clash of the idealist and the empiricist. I find that, I think it's deeply misleading. I much prefer to see them as intellectual allies.
Allies? How so?
Their disagreement over where the perfect forms are in some other realm or right here in things, that's a family squabble.
So what's the common ground then? The bigger picture?
The common ground is their shared, powerful commitment to forms. The idea that things have a fixed, stable nature. Whether it's the ideal circle or the species horse, they both agreed that you need these fixed, eternal structures to explain the world.
So the real philosophical battle line wasn't between the two of them?
Not at all. The crucial divide was the two of them together against everybody else, against the skeptics, the atomists, the relativists, the people who said stable knowledge just isn't possible. They were, in a sense, fighting for the very soul of science.
And this is where it gets so fascinating, because that principle of fixed eternal forms just bleeds into everything, into his physics, his whole cosmology. Let's get into the 3 pillars of his universe.
The first one is, I think, the hardest for us moderns to really wrap our heads around. Temporally, the universe is eternal and everlasting.
Meaning, no beginning and no end.
No beginning, no end.
What does that do to theology and philosophy? A universe that wasn't created.
It changes everything. It means no creation event, no Big Bang, no Genesis story. And of course, if there's no beginning, there's no apocalypse. No end of the world, which means no final judgment.
So the cosmos isn't going anywhere.
It just is a static, perpetual reality. The second feature is spatial. The universe is spatially limited, it's finite, and crucially, it's geocentric.
We're at the very center of everything.
Exactly. We aren't some random accident in a forgotten corner. We are the center. And the third feature ties it all together. The main structures, the species, they're fixed. Unchanging.
So a frog is a frog is a frog. The form of frog is eternal.
Eternally a frog. It cannot change. And this doctrine, this bedrock of fixed eternal forms, is what the scientific revolution had to spend centuries laboriously dismantling. From Copernicus to Darwin. You can't appreciate how revolutionary they were until you feel the sheer intellectual gravity of the system they were pushing against.
And that system had its own mechanics, its own physics. He didn't just have one universe with one set of rules, did he?
No, and that's the key. It's a two-part structure. You have the messy, corruptible sublunar realm that's here below the moon, and then you have the supralunar realm, everything beyond the moon's orbit.
And up there, it's perfect.
Up there, it's perfect, unchanging, predictable, regular, and this is critical. It's mathematical.
And how does that perfection show itself in the way things move?
The motion has to be perfect, too, so it's purely circular.
Why circular?
Because the circle is the only form of motion that is, in a sense, eternal and self-contained. To move away from your starting point is also to return to it. It's sustainable.
The composition of things up there is different, too.
Completely different. It's not earth, water, air, or fire. The heavens are made of aether, the quintessence, the fifth element, light, perfect, unchanging. And one more thing. There is no vacuum, no empty space.
Nature abhors a vacuum.
That's the famous line. For him, for something to move, it had to push against something. Empty space meant motion wasn't possible.
But the astronomers, even then, were incredible observers. They could see that planets like Mars didn't move in perfect circles. They wobble. They even seem to go backward sometimes. Retrograde motion.
And that was the great problem. The observations were good. But the foundational assumption that heavenly motion must be circular was too beautiful, too logical to give up.
So instead of changing the theory, they complicated it.
Massively. They introduced epicycles. So to save the perfect circle, they started putting circles on top of circles. Imagine a small sphere spinning on the edge of a much larger spinning sphere.
That sounds incredibly complicated.
It got insane. By the end, some models had up to 55 interconnected spheres, all just to make the wobbly path of Mars look like it was made of perfect circles.
It's like having a broken piece of software. But instead of fixing the core problem, you just keep adding patch after patch after patch.
That is a perfect analogy. The system became monstrously complex just to protect one simple, elegant but wrong idea. And that shows you what Kepler and Galileo were up against. They weren't just fixing an astronomical model, they were attacking the entire architecture of reality.
Let's bring it back down to Earth, though. From the stars to to the mud. Because we forget that maybe a quarter of his surviving work is biology.
A huge amount. And he was a brilliant observer of that middle scale of things you can see with your own eyes. His model worked incredibly well for everyday life.
He was a real hands-on researcher.
Oh, absolutely. The records show him interviewing fishermen, farmers. There's strong evidence he got animal samples like elephants and monkeys sent back from his former students' campaigns.
He practically invented zoology from scratch.
He did. A lot of his most detailed work on marine animals is thought to come from his time near the Lesbos Lagoon, where he could just sit and study life in the tides.
But this is also where we get one of his most famous errors.
Yeah.
The claim that women have fewer teeth than men.
Yes, the infamous tooth count.
Yeah.
And it's so scrutinized because, well, why would this meticulous observer make a mistake he could have corrected just by asking his wife to open her mouth?
Right.
The theories range from, maybe observing women who were sick and had poor dental health to something much deeper, confirmatory bias.
Meaning he saw what his philosophy told him he should see.
In a way, yes. His whole system tended to place the female principle in a more passive material role. For instance, he believed all the genetic information, the form, came from the male. The female just provided the matter, the container.
Form is superior to matter.
Exactly. So this predisposition to see the female as somehow less complete might have subconsciously led him to look for and find evidence of it, even in something as simple as counting teeth.
And yet, despite that, I heard a modern biologist, a geneticist, said he should have won a Nobel Prize.
That's a fantastic story, because what the geneticist recognized was that even though the mechanics were wrong, he grasped the fundamental principle. He understood that there has to be some kind of informational blueprint, an abstract form that tells matter how to organize itself into a living thing.
He was thinking about DNA before anyone had a clue what it was.
Conceptually, yes. He was asking the right question, which is often the genius part.
So let's pull back to the grand cosmic scale. We've got this eternal two-tiered universe. But if it wasn't created and isn't going anywhere, why does anything move? What's the engine?
This is maybe his most elegant idea. The power source is the unmoved mover, his version of God.
Okay, but this God doesn't create anything or destroy anything.
Correct. No creating, no destroying, no judging. It has almost no direct relationship with us at all.
So if it's not pushing or pulling, how does it move the entire universe?
It moves everything not through force, but by being the ultimate object of universal love and desire.
Desire. Desire is the engine of the cosmos.
Isn't that beautiful? The mover is perfect thought, thinking only about itself. And since all change implies some kind of imperfection, it has to be perfectly still. Everything else in the universe, from the biggest star down to the smallest ant, is striving to imitate that perfection as best it can.
So the planets and stars move in perfect circles because that's their way of imitating the mover's eternal stillness.
It's the closest they can get. And for us down here, mortal creatures, we imitate eternity through reproduction by continuing this species.
And for a person, the highest imitation is thought.
Pure contemplation,
Mhm.
Theoria. Because that's the closest a human can get to the mover's own activity of pure self-contained thought. Every single thing is just automatically trying to fulfill its own nature, its telos, which is a kind of yearning for its own small piece of perfection.
It's like a giant cosmic clockwork, but the gears are all turning because they're attracted to the center, not because they're being pushed.
And that's why his philosophy was so influential for later mystical traditions. He provides this ultimate philosophical reason for all the striving and energy we see in the world. It's all driven by a kind of love.
You can really see why he felt like he'd solved it all. He built a system where humanity's mind and the cosmos were made for each other. It gave such profound certainty.
And that certainty is everything. He put us at the center of a knowable, finished, perfectly arranged universe. And the process of tearing that down, of removing us from the center, that was a profoundly painful experience for humanity. It was the birth of the modern age.
It makes you think about all the scaffolding that had to come down before we could even ask our modern questions.
Absolutely. And I think that's the final lesson here. He built this incredibly complex system to protect a few beautiful core assumptions. It makes you ask yourself, what seemingly obvious common sense assumptions are we clinging to today? About consciousness or time or reality? What elaborate patches are we building just to protect a beautiful idea that future generations might find, well, laughably flawed?